Hello, Algebra 2. Today we're going to be looking at section 12-1. It starts our statistics and probability stuff, and it is experiments, surveys, and observational studies. We're going to have two objectives for this. The first is to distinguish between experiments, surveys, and observational studies. That is, know the difference and when to apply the right one. And to distinguish between correlation and causation, which is going to be it's a big deal, and I'll talk about that as we go through the notes. But first, let's talk about what a survey is, what an observational study is, what an experiment is. So let's talk about each of these individually. Okay, a survey is gathering information. It's a very passive thing. It's something where you don't interact at all, or interact very little. You're not doing anything to measure an outcome of any sort. You're just gathering information. An example of this would be taking a poll, like for an election or something else, anything really. For example, I could ask you guys how many people believe that learning from home is working, how many people believe that learning from home doesn't work and they need to be in a classroom. So that would be a survey. Okay. An observational study, on the other hand, is a little more intrusive, I guess you might say. It's a good way to put it would be that it is observing. I know that's kind of using the word in it, but observing without influencing results. So an example of doing that might be let's say you observe a 100 people and 50 are taking a new treatment or any sort of treatment at all. That is, they're taking a new pill, or they're just taking a pill. For example, you might have 100 people that you know get migraines regularly, and 50 of them are taking something for it, and 50 of them are not. So you observe that, and you collect data, analyze that data, and you try and interpret the results. Okay, so that's an observational study. Now, the last one is the most intrusive one. It is an experiment. Okay? And an experiment is where you do something. And observe the response. Okay, you actually do something to purposely change the environment. Okay, for example, you might study you might do an experiment where you study two groups. One gets a new medicine. One gets a placebo. So you're actually trying to see let's say we talked about migraines again. If I have a group of 100 people that I know get regular migraines, and I tell them, here, if you take this medicine, you're not going to get so many migraines. It's going to be preventative medicine. You're not going to get as many migraines if you take this pill every day. And for 50 of those people, I actually give them the pill. And for another 50, I give them a fake pill that I know does nothing, just like a sugar pill. Okay? And then I see whether or not the people taking the actual pill have less migraines than the people taking the placebo. I misspelled placebo here. It's actually with an E. Sorry about that. A placebo is something that doesn't work the way people think it do, but because they think it works that way, it works for them. So the placebo effect can be a powerful thing. So those are our three things. You can have a survey where you just very passively gather information. You can have an observational study where you observe something, but you don't do anything to interfere with it. And then you can have an experiment where you do something and actually interfere to see what different results you get as you interfere. Okay? So then the question is, can we figure out the difference between these? So example 1 is this a survey, observational study, or an experiment? So let me give you the scenario here. 25, oh, it says 20 on here, I'll stick with that. 20 males randomly separated into two groups. So we take 20 males, we put them into two groups, and you might call this group A and group B or something like that. One group gets a new trial medication. The other gets a placebo. Now, right away here, you should see that there's a giveaway here, and it's that word placebo. Anytime you're talking about giving one group a placebo, then you're talking about an experiment. So the word placebo really tells me that this is an experiment. You're also going to be asked about whether it's biased or not. In your exercises, is there a bias here? That's always a difficult question to answer. We're testing only males, so that helps us be unbiased towards females and stuff because we've just eliminated that. Although you could argue that because we're only testing males, why are we only testing males? Well, maybe it's a medication that only affects males. I'm not going to say any more than that. But then, so males helps us in some ways to not be biased, but the big thing is randomly. Is there a bias? No, because groups are chosen randomly. And that's the big thing. As long as you're choosing things randomly within the context of what you want to study, as long as you're choosing your groups randomly in an experiment, then you've got a pretty good chance of it not being biased. Whether you're actually choosing them randomly is always an interesting question. So let's go to our next board and let's talk about example 2 here. Should we do a survey, observational study, or experiment? So this time I'm going to give you a scenario, and I want to know which one should we use. Here's what we want. We want to know how students and parents feel about school uniforms. I want to know how students and parents feel about school uniforms. So if this were, let's say, an observational study, if we were going to do this as an observational study, we would want to give them something and see how it affects them. So if this question were that we asked half the kids in a school to wear a uniform and tell the other half that they don't have to. And then we asked parents and students after a semester or a quarter, if we asked them how they liked the uniforms, that would be an observational study. But it doesn't say that we want to know how they feel after wearing uniforms. We just want to know how they feel about school uniforms. So this wouldn't be an experiment either, because in an experiment we would randomly assign, okay, you guys are going to wear these uniforms, you guys are going to wear these uniforms, and we try and figure out which ones work best and which ones affect your study habits best and things of that nature. So what we're really talking about here is a survey. We're just trying to gather information. Survey, and that's because we're just trying to gather information. All right, so that's which one we would want to use there. All we want to do is gather the information, so we would just use a survey there, okay? Let's talk about correlation versus causation. Correlation versus causation. I think what I'm going to do is tell you what they are first, and then I'll talk about the difference between them. The difference between them is the difference really between understanding some really important things. This is a pretty important subject here. So let's talk about correlation first. Correlation is that one thing happens and another thing is likely to happen. And I am going to underline the word likely to happen, because correlation does not mean that because this thing happened, this thing automatically happens. Instead, it means, hey, I noticed that every time, not every time, but most of the time when this one thing happens, another thing happens. Okay? Correlation would be something like, I'll give you the one that's in the study guide. A correlation is the pond, some pond is frozen. It's likely to snow. Now, just because the pond is frozen doesn't mean it's automatically going to snow, but the temperature is low enough, the environmental condition is right for the chance of snow. Correlation is like weather prediction. they're able to see certain things on their radar, and they're able to say, okay, chances are pretty good that it's going to rain, or it's going to snow, or we're going to have sunshine today. But they can never be 100% sure, as we all know in Michigan. So when you think of correlation, think of weather prediction, that sort of thing. They understand that it's very likely to happen because of the data that they have, but that doesn't guarantee anything. On the other hand, causation. One thing happens because another thing happened. And this is guaranteed. If you've got causation, you know it's going to happen every single time. Okay? The example that they have in here is if you turn on a light, the room brightens. I'm going to give you another one that you may or may not be aware of, and you may try and argue with me about, but I promise you, this is absolutely causation. A lightning strike causes thunder. There is absolutely no way to have thunder without lightning, and there is absolutely no way that lightning happens without there being thunder. Now, whether you can hear that thunder is another question. Sometimes the lightning is so far away that the sound can't travel that far. But guaranteed, every time there is a strike of lightning, there is a roll of thunder that accompanies it. Every single time, it is a causation thing. Okay? So let's talk about an example here. This is example 3 for our notes. And this is a very simple question. Correlation or causation. And here's the scenario. Children who live in very large houses usually get larger allowances than children who live in small houses. So the question is it correlation or causation? And one of the big clues here is this word usually. Okay? And one thing you should ask yourself is, does the word usually make sense in the context as I'm reading it? So that's what I want you to think about as you're answering these types of questions, these scenarios. Could you put in the word usually and have it make sense? If you can, then it's correlation. Okay? Correlation is something that usually happens. Causation is something that always happens. So if you can put in the word usually, then it's correlation. If you can put in the word always or every time, then you're talking causation. All right? Those are the notes for section 12.1. Thank you.